Welcome to MrCScience.com's video on Experiment 1.1 for General Science. We're going to do Experiment 1.1, which is density in nature. They use it as kind of an example of how Democritus tried to show that everything was made of atoms. So we'll do the experiment, then talk about it a little bit. What we're going to do in the experiment is we're going to pour together a few different liquids of different varying densities: oil, water, corn syrup, and we're going to add a few items: cork, grape, rock, and also some ice, which I have in the freezer right now. And we're going to see where everything breaks down. These three liquids don't readily dissolve in each other, although given a little bit of time, water and corn syrup will dissolve into each other. But so they will make some nice little gradients for us to look at. So let's walk over and talk about the experiment. So this is our first experiment that we're doing in class, and we'll use it to show how to write up experiments going forward. We write up all our experiments as if they were college labs or actual labs in a scientific laboratory. The reason that scientists write up labs is that if they find something interesting, they need someone to verify their work. They can pass on the lab, and the lab will have all the information that the person needs to try the experiment on their own and confirm their hypothesis. So let's go ahead and write up our first lab. So in class will be, if you're in one of my in-person classes, you'll have a laboratory notebook. You'll use a new page of that. Otherwise, either a new page of paper or a word processor, a new sheet on your word processor to do this. So go ahead and go to a new page or a new sheet. And what we're going to do is we're going to, at the top, put Roman numeral number 1, period, and title. Every lab should have a title. Let's make that a little bit, no, that's a good size. Okay, title of this lab is Density in Nature. So every lab has a title. So now in the next line, Roman numeral number 2, period, purpose. If any of your lines need more than one line, that's fine. Just wrap it around and then go to the next line for every new Roman character. Purpose is why we're doing the lab, and we're going to use it to demonstrate how Democritus believed everything was made out of tiny particles called atoms. Okay, we're going to go to our next line, Roman numeral number 3. Oops, and we're going to do our hypothesis. If I'm going too fast for you, the nice thing about videos is you can pause the video, catch up, and then continue on. So hypothesis. A hypothesis is an educated guess as to what's going to happen, what you're testing in the lab. So Democritus said that everything was made up of atoms, and depending on how tightly packed those atoms were, things had different mass or different density. Density is the amount of mass you have in a certain volume. So the more stuff you have stuffed into the same volume, the heavier it's going to be, the more dense it's going to be. Our hypothesis is going to be that lower density objects float on higher density liquids. So that's the theory we're going to test. Lower density objects float on higher density liquids. Okay, Roman numeral number 4. Materials. This is a very in-depth, comprehensive list of everything that you've used for the lab, so that if that needs to be recreated, they can recreate it precisely how you did it. That being said, in our class, the labs are pretty basic. We're just going, I don't want to waste our time writing out all the materials, so we're going to say as per text. So they can look in our textbook if they need to recreate the lab. Roman numeral number 5. I can't type. Procedure. Procedure, similar to materials, is a very in-depth and explicit list of exactly what we did in the lab, how to carry out the lab exactly, so that if it needs to be reproduced, they can do exactly what you did. Again, we're not going to waste our time in class writing out the procedure, so we're going to say as per text. Okay, Roman numeral number 6. Observations. This is where we record any data we find or observations we see to be analyzed later. So this is where the actual experiment occurs. So if you don't have all this written down yet, pause the video and finish writing it down, and we're going to go over and start our lab. Okay, so we're here, we've got our graduated cylinder. I'm using that. They say use a glass, but this is nice. It gives us a good look at what's going on with the different liquids. So what we're going to do is we're going to start with our vegetable oil. Let's try to pour it down the center so that we don't get it all stuck on the sides. And we're going to add some vegetable oil. There we go. Okay, so vegetable oil. Hey, we already have a density. Well, one liquid more dense than another, although you may not realize it. Oil is more dense than the air around it, so oil sinks through the air, or the air floats on top of the oil. So now we're going to add another liquid, water. This one I'm going to pour down the side to kind of avoid bubbles. We'll get some bubbles, but not as much. There we go. So I've poured my water in my oil. We've got some bubbles here, but we got the water underneath and the oil on top. So water is more dense, more tightly packed than the oil, so the oil floats on top of the water, or the water sinks through the oil. Now we're going to add our next substance, corn syrup. Now corn syrup is more dense than both oil and water, so guess where it's going to go? So this one I'm going to pour down the middle. We'll get some bubbling, not too bad, because corn syrup is also very viscous. It tends to stick to itself pretty well. So we shouldn't get a lot of bubbles. There we go. Poured a bunch of corn syrup in there. And it's already settling. Put our cap on so I don't end up sticky everywhere. Okay, so now if we look, we've got our corn syrup on the bottom. It's the most dense. Our water in the middle, which is always turning a little brown because the corn syrup will dissolve in the water. And then we've got oil on top. We got our 3 dense liquids. So now let's go ahead and record that as our first observation in our lab notebook. So sometimes it's good just to write down our observations in text, but sometimes it's good to draw them. So here's a good opportunity to draw in your lab notebook. When I grade your lab notebooks, I do not grade on your drawing. If you can't draw on a word processor or something like that, then you'll have to do a text version. So I'm going to get ourselves a graduated cylinder. I've already drawn it. Okay, so here's our graduated cylinder. So now what I'm going to do is I'm going to add our lines. And here's our bottom down here. So this down here is our syrup. Sorry, I don't have my stylus, so I'm drawing with my mouse. And there we go, our syrup. Syrup is the most dense, went to the bottom. In the middle is our water. This is science class. You can write H2O. Cool. And then on top is our oil. Okay, there is the beginning of our observations. So syrup, most dense on the bottom, water, slightly less dense, oil, least dense on top. Okay, so now let's go ahead and add our objects. Okay, so here we've got our graduated cylinder. Let's start with our rock. Rock is obviously very dense. Where do you think that's going to go? Let's drop the rock in. Loop. And you can kind of see it through the dark right here. The rock went all the way to the bottom. Okay, now let's drop in our grape. Grape is a little different. It's primarily water, but there's also some plant material there. If we drop our grape in, let it sit for a second. And our grape is actually floating. There it goes. It's going to say a grape is slightly more dense than the water, but it's less dense than the syrup. So the grape sits on top of the syrup. Okay, now let's drop in our ice cube. There's our ice cube. We gotta let the air kind of get out of it. Let the oil kind of saturate here. See, we got a big old air bubble stuck in the middle there. Sometimes we gotta help things along a little bit. Get that air bubble off of there. Okay, let's see if that worked. We still got oil trapped. I'm using a bit of a large ice cube here, so that's part of our problem is our oil is being trapped in between. So let's spin the ice cube around a little bit. Make sure we get all the water, all the air off of it. Now, ice is made out of what? Oops, moved my camera. Ice is made out of water, but the molecules are slightly less dense in the way they pack, so there's less stuff in the same amount of volume. So ice is actually less dense than water. That's why it floats on top of water, and one of the reasons we can have life in the northern climates like up here in Minnesota, because the lakes won't freeze solid then. Okay, then finally our cork. Our cork is the least densely packed of all the materials we got there, so it floats on top of the oil. So if we take a look at this, we got our rock, which you can't really see in the dark syrup down there. We got a grape floating in there, our ice in between the water and the oil, and our cork on top. So let's go ahead and draw those objects in our lab notebook. So let's the computer. Okay, so let's start with our rock. Let's add our rock down here. Okay, our rock is the most dense. It went to the bottom. Oh, I gotta get my stylus out. Okay, then our grape. Oh my goodness. It's like I'm just learning how to write. Okay, grape floats in between the syrup and the water. And then on there we've got our ice. Ever hear of an iceberg? Well, that's kind of what an iceberg is. It floats on the top of the water, but it's also in it. So our ice is right there, and finally our cork. There, I'm getting used to drawing. I'm writing with my mouse again. Okay. So our syrup was on the bottom, our water in the middle, our oil on top, and then our rock went to the bottom of everything. Our grape sat on the layer of our syrup and our water, our ice sat on the layer of our water or oil, and our cork floated on top of the oil. So there's all our observations for this lab. Normally I'd ask, are there any other observations we should make? Probably use a smaller ice cube, but kind of interesting. So, okay, so let's go ahead and finish up our lab then. So let's go down below our observations, and we're going to do Roman numeral number 7, conclusion. Okay. Conclusion is the most important part of the lab. Why, you may ask? Well, it's worth half your lab. There may be opportunities or times in this course, when I have you do your own conclusion, if you forget to do it, that's 50% off of that lab. Most of the time we'll do it all together, so labs are usually an easy 100%, so that's good. So, conclusion. What do we do in our conclusions? We restate what happened. Okay, so we found that the syrup went to the bottom, water in the middle, and the oil went on the top. Well, I'll let you in on a little hint. Syrup is the most dense, water is the next less dense, and then oil is the least dense. So we found the denser liquids sank in the less dense liquids. So that's an easy way of kind of recapping and saying, instead of saying everything that happened there. And then we dropped the rock into it, and it went to the bottom of the syrup. What does that tell us about the rock? So the rock sank to the bottom, so its density is what? Compared to all the other liquids, its density is greater than the liquids. Okay. Next we dropped in the grape. The grape sank to the bottom of the water, but stayed at the top of the syrup. So what does that tell us about the density of the grape? The grape is more dense than the water because it sank through the water, but less dense than the syrup because it did not sink into the syrup. It floated on top of the syrup. So in knowing that, what do we know about the ice? The ice is less dense than the water because it floated on top of it, but more dense than the oil because it sank through the oil. The cork floated on top, so what do we know about the density of the cork? The cork floated on top, so it was less dense than all the liquids. The cork is more dense than one thing. Can you figure out what that one thing is? If you can, I'm tempted to have you just let me know, but I'll give it away. It's more dense in the air. The cork, we didn't let go of the cork. It didn't float up into the air and off into the upper atmosphere. So density plays an effect on our atmosphere as well. In fact, a vacuum has zero density. It's absolute. There's nothing in it. So that means that our atmosphere will sink in a vacuum. So luckily, it'll stay on the planet. It won't float off into space. So okay. So we kind of restated everything that happened. We did a little analyzing there. Another thing we do in our conclusions is address our hypothesis. Our hypothesis was lower density objects float on higher density liquids. Well, we just saw that. You relied on me for the density, but if necessary, we could have measured the density of each of these objects. So based on this, whoops, make sure my mouse is in the right place. Our hypothesis was correct. There we go. And you've completed your first lab. So if you wrote down everything like I did, and I don't grade you on your drawing, I grade you on your labeling, so, and you labeled everything, you got 100% on your first lab. Yay, we're on our way to an A. So If you have any questions on this, feel free to drop me a line at mrc@mrcscience.com. Thank you.